Hi guys, it's Miss Manili again, and I am going to complete your final exam review packet. This time we're working on the non-calculator section, so you have to be able to do every single one of these problems without a calculator. We're going to start with our trig section, and again, this is a section you guys did really well on, so I expect you guys to do pretty well on the final exam. So in number 14, you're just asked to complete the table using what you know about the trig functions, the sine, the cosine, and the tangent. We're going to first look at the relationships with those trig functions to the unit circle, and then we're going to look at the relationship of those functions with respect to a right triangle. Because sometimes we're dealing with values that are on the unit circle that are within like one radius. Our unit circle, remember, is a unit of 1 as its radius. If it's not on the unit circle, then we have to revert back to what we remember about right triangles and the Pythagorean theorem. So on a unit circle, when we're dealing with, let me do the unit circle, I'm just going to sketch a unit circle right here, right? We've got our x and y axes, and so any angle, so if I call this theta, for example, we've got a point on the unit circle that corresponds to x and y. And so if I want to find the sine of theta, and remember, the whole reason that we're able to do these relationships is because it actually does revert back to a right triangle, where this length here corresponds to our x value, this height here corresponds to y, and the length of our hypotenuse is 1. So if we think about the sine function, and actually I can relate both the unit circle and the triangle, the sine function, remember, is just opposite over hypotenuse. So let me do that with the triangle first. It's opposite over the hypotenuse. And so if I revert that back to the unit circle, and here's theta now, so I've got the triangle flipped, but the opposite side corresponds to y, and my hypotenuse is 1 unit long. And so the sine, if I'm dealing with points on a unit circle, looks like y over 1, which simply reduces to y. If we're dealing with cosine, remember, it's the adjacent side over our hypotenuse. So adjacent over hypotenuse. And if I go back to my unit circle, the adjacent side is what we're calling x. The hypotenuse, again, is just 1. So cosine refers to x over 1, or simply our x-coordinate. The tangent, remember, is opposite over adjacent. And if we revert back to our unit circle, the opposite side, again, is y. Our adjacent side is x, and so the tangent is just going to be y over x. And so if you're given an ordered pair on a unit circle, you can use these relationships. If the ordered pair that you're given is not on a unit circle, then you have to draw a triangle in the appropriate quadrant and then construct the sides based on what you know about the Pythagorean theorem. Let's take a look at number 15. It says, suppose the sine of theta is 0.819 and the cosine is equal to negative 0.574. So which quadrant does theta lie in? So think about it. Your sine is positive, your cosine is negative. The sine, remember, corresponds to your y value. So we have a positive y value and a negative x value. Well, let's take a look at our coordinate plane. If x is negative, I know I'm dealing with quadrant 2 or 3. If y is positive, then I must be dealing in quadrant 2. And then in part B, it says, without using a calculator, which is the value of the tangent? So let's think about it. We already know that our tangent is going to be opposite over adjacent, y over x, which is the same as saying sine of theta over the cosine of theta. And so if my tangent is going to be the sine over the sine we said is 0.819, and the cosine is negative 0.574. So let's think about this relationship. It doesn't matter that you don't have a calculator. You have 4 different options. First of all, I'm dividing a positive number by a negative number. So I know my answer has to be negative. So that eliminates this and this. Now let's take a look at the numbers. 0.81 is larger than 0.57. So I know that when I'm dividing, I'm going to have a number that's bigger than 1. And there's only one option, and that is going to be the tangent of theta is equal to negative 1.43. If the fraction was the other way, if it was 0.57 over 0.81, I know that my value is going to be less than 1. But if it's an improper fraction, remember the value has to be greater than 1, and you should be able to use, deductive reasoning to choose the correct answer. In number 16, you're asked to factor. I did include all of our factoring rules. I did include the flow chart here. Now, this is something that you guys are going to have to remember how to do. Remember, the very first thing you always want to look at is there anything in common that can be factored out? Once you've factored out the greatest common factor, you're going to count the number of terms. With a monomial, there's not much to do. Binomials, we're either dealing with perfect squares or perfect cubes. And then we have formulas that follow. With a trinomial, that's when we use the product sum method, where you're basically drawing the little table and you're looking at your product, which is a times c, and your middle term, b, which is your sum. And then we talked about using the slip slide divide method or grouping when the a value in that trinomial is something other than 1. Whenever you have 4 terms, it's best to use grouping. And anything more than that, we need to use a combination of graphing and division when factoring. So each of these refers to some basic factoring rules. So if I look at letter A, the very first thing I want to look at is there anything in common that I can factor out? And there isn't. So I've got 2 terms. I want to look now. Do I have perfect squares or perfect cubes? And it is expected that you guys remember those basic, those perfect powers so that you can recognize 16 is a perfect square. So is x to the 4th. If it's got an even exponent, you know it's a perfect square. So I know I'm going to use my difference of squares formulas, which looks like this. A squared minus b squared is equal to a minus b times a plus b. And so now I got to identify what a and b are. Even though x to the 4th and 16 are also perfect 4th powers, I want to be careful because I don't have any rules for perfect 4th powers. I only have rules for perfect squares and perfect cubes, so I need to think about taking the square root of each of these terms. That means that my a term is going to correspond to the square root of x to the 4th, which is x squared. My b term is going to correspond to the square root of 16, which is 4. Sorry, I was getting ahead of myself. So now if I factor, that means it's going to be x squared minus 4 times x squared plus 4. Now, when we factor, if we still have x squares or x to the 3rds, we do want to see if we can break it down any further. And so I notice again that I've got 2 binomials, and they're both perfect squares. The first quantity is, again, a difference of squares. When I take the square root of my terms, I'm going to have x and 2. So I'm going to have x minus 2 times x plus 2. That's how that breaks down. But we don't have a formula for x squared plus 4. We don't have a formula for the sum of squares. So x squared plus 4 is prime, and so I'm just going to bring that straight down. Let's take a look at letter B. Again, we have a binomial, x to the 3rd plus 8. Got to be careful here, though, because this time I'm dealing with perfect cubes, and so I have a different formula for perfect cubes. And if we look, so here are my perfect square formulas. Notice that we have a formula for the difference of squares, but not for the sum. When we're dealing with perfect cubes, we have 2 formulas we can use. We have one for the difference and one for the sum. So in this case, we have the sum. I need to find the cube root of each term. So in this case, I'd let my a value be x. The cube root of x cubed is x. The cube root of 8 is just 2. And so in my formula, if I have a cubed plus b cubed, that's going to correspond to a plus b, and then the next is a trinomial. That's going to be a squared minus ab plus b squared. So let's fill it out. A plus b is going to correspond to x plus 2. A squared is now going to correspond to x squared minus ab. Well, if I multiply x times 2, I'm going to have 2x, so it's going to be minus 2x plus b squared is 4. If we take a look at letter C, we've got x to the 6th minus 64. I think this is actually one of the problems from your unit review. Now, both of these numbers are perfect squares, and both of these numbers are also perfect cubes. In this case, it's actually going to be easier to use your difference of squares formula. And if I take the square root of x to the 6th, that means my a value is going to be x cubed, and my b value is going to be the square root of 64, which is 8. And so when I factor this, I'm going to have x cubed minus 8 and x cubed plus 8. Now if I look at each of these quantities, they can be factored again because they're both perfect cubes, and I have a formula for both the difference and the sum. The cube root of x cubed is x. The cube root of 8 now is 2. So with this one, I'm going to have x minus 2. And then the trinomial is x squared plus 2x plus 2 squared, which is 4. The other quantity is x cubed plus 8. And so that can be factored into x plus 2 and x squared minus 2x plus 4. So that's both your difference of cubes and sum of cubes formula. So we take something that's actually very simple and turn it into something that looks very complicated. In letter D, this is a trinomial now. There's nothing in common for me to factor out. And so I'm going to look at my product and my sum. My product, remember, is a times c, and a is 1, c is negative 40. So my product is negative 40, and my sum is 6. So I'm looking for numbers that multiply to give me negative 40 and add to give me 6. So I might start off with like negative 4 times 10. And when I add them, I get a positive 6, and so that works. So those are the two numbers. When I think about breaking down x squared, I know when I break it into two quantities, I'm going to have an x and an x. The numbers that I get from this little tree are the numbers that I'm going to put in my factors. So it's going to be x minus 4 and x plus 10. And if you FOIL it back out, you should get what you started with. Letter E. If I look at my terms, there's nothing in common that I can factor out. But this time, I have a 6 in front of x squared. And that complicates things. When I look at my product, again, it's a times c, and that's going to be negative 18, because I've got to do 6 times negative 3. My middle term, b, is my sum. So I'm looking for numbers that multiply to give me negative 18 and add to give me 7. So I'm looking at 9 times negative 2. Now, there's two ways you can do this. I think the easiest way is to use like the slip, slide, divide method as opposed to grouping, but you can use grouping as well. And I'll show you how to do both. So if I use the slip, slide, divide method, basically I don't know how to break down 6x squared. Am I going to have 6x and x in the other quantity? Am I going to have 2x and 3x in my quantities? It's hard to tell. So what we're going to do is just do 6x and 6x. But I've got to note I've got an extra 6 that I've got to factor out, okay, that does not belong. And so now I can do what I did before and just do plus 9 and minus 2. But the problem is I have to factor out a 6. So it doesn't mean that I have to factor out a whole 6 from each or from one of the terms. I just need to factor out a total of 6. So if I look at the first quantity, I can divide out a 3 there. If I look at the second quantity, I can divide out 2. And 3 times 2 is 6, so I am pulling out that extra 6. This is the divide part. So now I'm going to divide both of the terms in my first quantity by 3, and that leaves me with 2x plus 3. In the second quantity, if I divide everything by 2, I'm going to get 3x minus 1. And if I FOIL it back out, I'll end up with what I started with. Another method would be to use grouping. And I don't want to confuse you by showing you more methods, but I know that some people find grouping a little bit easier. So with the 7x, notice that 9 minus 2 gives me 7. If we're going to use the grouping method, then what we do is we rewrite 6x squared plus 7x. But instead of writing the 7x, I'm going to write plus 9x minus 2x minus 3. And now I group. And that's exactly what we're doing in letter F as well. So the first terms, what I can pull out is a 3 and an x. That leaves me with 2x plus 3. In the second term, notice that I have this minus sign here. I have to pull out a negative. And since I really can't pull anything else out but with the 2x and the 3, I'm just going to pull out a 1. It means I'm dividing each of these terms by negative 1. So if I have a negative 2x and I divide out a 1, it becomes a positive 2x. If I've got a negative 3 and I divide out a negative 1, it now becomes a positive 3. Now notice that these quantities are the same. I can factor those quantities out front, and I'm left with 2x plus 3 and the 3x minus 1, which is exactly what we got when we used the other method. In letter F, I've got 4 terms. There's nothing in common in all of them, so I'm going to go ahead and use grouping again. And so with the 2x cubed plus 4x squared, I can pull out a 2x squared. And that leaves me with x plus 2. Notice again, I've got a minus here, so I'm going to pull out a minus 1. And I'm going to divide both of the next terms by negative 1. That's going to also give me an x plus 2. Now it's the x plus 2 that I have in common, so I'm going to pull that out in front. And that leaves me with 2x squared minus 1. Now, I do have the x squared term there, so the next thing I'd want to do is check to see if that could be factored any further. And even though 1's a perfect square and x squared is a perfect square, since 2 is not a perfect square, I can't use the difference of squares formula here. So it is considered prime, and that's as far as I can go in letter F. In number 17, you're given a polynomial of degree 4, and you're asked to write the function in factored form if you're given the zero of the function as x equals negative 3. So if I know one of the x-intercepts, that tells me that one of the factors is going to be x plus 3. And so if I know one of the factors, I can divide it out. So you could use long division, or since we already know the x-intercept, it's going to be a lot easier for me to use synthetic division. So remember, with synthetic division, we put the x-intercept on the shelf. A lot of people forget to do that. Because this is telling me I'm going to be able to write it in factored form, there should not be a remainder when you're dividing. So if you end up with a remainder, that's an indication you've done something wrong. Remember, with synthetic division, you want to make sure you have every term. So I have 4, 3, 2, this is x to the first power, and then no factors of x. So it's in standard form. I'm not missing any terms. I'm just going to list my coefficients. Okay, we give ourselves a little space. With synthetic division, we bring our number down. That's 1. Negative 3 times 1 is negative 3. I add, and I get negative 2. When I multiply negative 3 times negative 2, that gives me a positive 6. When I add, I get 1. Negative 3 times 1 is negative 3. When I add, I get negative 2. And when I multiply, negative 3 times negative 2 is positive 6. Sorry, positive 6. And when I add, I get 0. And I need to get 0 because that means that there's no remainder. And so what that tells me is that I've got the next term. So remember, if I'm starting off with x to the 4th, what I have left now is going to be 1x to the 3rd minus 2x squared plus 1x minus 2. So that is not completely factored. Now I have to go back to my rules of factoring. Since I've got 4 terms, I'm going to use my grouping method. And so in my first pair, I can pull out an x squared. And what's left is x minus 2. This time I've got a plus in the middle, so I'm just going to pull out a plus. There's nothing that I can really pull out of x minus 2, so I'm just going to pull out a 1. And again, that leaves me with x minus 2. The x minus 2's are in common, and so when I write this in final factored form, I'm going to have x minus 2 times x squared plus 1. But remember, I had this factor to begin with, which is x plus 3. So now my function, which we're calling f of x, in factored form, looks like this. And remember, if the degree is 4, then I should have 4 factors of x. So I can double check. This is one of them in the first one. So 1, 2, and then this is squared, so this is 3 and 4. So there's my 4 factors of x. Letter B says to sketch the graph of the polynomial on the axis below. The graph does not need to be to scale. So this is a place where you really want to start thinking about what your roots are. And so if I have my factors, so for example, if I know that x plus 3 is a factor, if I set that equal to 0, it'll help me identify the x-intercept, which I already know is negative 3. If I have x minus 2 as a factor, if I set that equal to 0, that tells me that x equals positive 2 is a root. If I have x squared plus 1 equals 0, that means that x squared is equal to negative 1. And if I take the square root of both of that, I end up with an imaginary root. So I know I'm going to have plus or minus. The square root of negative 1 is I. Remember, all of your imaginary roots are going to come in pairs. They're going to be complex conjugates of each other. So this is what I know. I've got an x-intercept at negative 3. I've got an x-intercept at positive 2. And then I have an imaginary root. So if I look at my leading term, so remember, my degree is 4. That tells me it's got even end behavior. And so I can sort of start talking about letter C, where it's asking me to relate the short and long run behavior of the graph to the equations in standard and factored form. So if we think about it, the leading term, I'll just write this out as I'm going, the leading term is x to the 4th. This tells us the end should be going in the same direction. Oops. Since it's even degree, they should go up because it's positive. Okay, so I know my even end behavior, my arrows should be going up. Okay, I know I have x-intercepts at -3 and +2. I'm just going to say this out loud because I'm running out of space. I know I have x-intercepts at -3 and +2 because of the factors x plus 3 and x minus 2. I know that they're single roots because there's no power to either one of those factors. And I also know that we have imaginary roots at positive and negative I, which means that I'm going to have an extra turning point somewhere. So what that means is, and with imaginary roots, basically you have an extra turning point that doesn't hit the x-axis. So that means down here somewhere, I want to have the graph turn without hitting the x-axis, and that's going to be your imaginary roots. So that's a sketch of what this function would look like based on what you know about the long-run behavior. That tells you that the ends should be pointing up. The factors tell you where it's going to cross the x-axis. The fact that you have some imaginary roots tells you there are going to be extra turning points that don't hit the x-axis. All right, and number 18, this is just matching. So you want to make sure, notice that there's no numbers, so this is a problem that you cannot put in your calculator. You really need to understand the long-run behavior of the functions. So you want to make sure all the equations are in standard form, and as I'm looking at it, they all are. And so we want to look at the leading term. So in this case, our leading term is a positive a to the third. It's got an odd exponent that tells you that the ends should be going in opposite directions. It's going to look like an S from far away. Since a is positive, it needs to be increasing to the right. The only graph that does that is number 4. In letter B, now we're dealing with negative a x to the third. So this time again, we have odd end behavior, but since a is negative, we want to make sure that our graph is decreasing to the right. And so that's going to be number 3. In letter C, we've got negative a x to the fourth. The exponent is even, so I know the ends are going in the same direction. Since a is negative, they must be going down. And so that is going to match the graph for number 1. Obviously, that leaves number 2. That's going to be your even end behavior that is going up. And so that's going to be the graph of number 2. All right, just a few more left. All right, number 19, it says to evaluate each without a calculator. We will give you the unit circle, but you'll notice that some of these values are not on the unit circle, so you really do have to understand the relationship. If you have, for example, a value that's more than 2 pi or more than 360 or a number that is negative, you have to remember how to adjust it. So in the first one, we're looking at the sine of 5 pi over 6. So on my unit circle, I'm going to see if I can find 5 pi over 6, and it's right here. Remember that the sine of 5 pi over 6 is corresponding to the y value of that ordered pair. So the sine of 5 pi over 6 is 1/2. The cosine of negative 45 degrees. Negative 45 degrees is not on your unit circle. 45 degrees, though, is. So here's a positive 45 degrees. Remember, a negative angle is basically the same distance, it's just going in the opposite direction. So a negative 45 degrees, if this is a positive 45 degrees, this would be a negative 45 degrees. So a negative 45 degrees corresponds to either 315 degrees or 7 pi over 4. And if we're asked to find the cosine, that means we're looking at the x-coordinate, which is square root of 2 over 2. Okay, the tangent of pi over 2. Well, here's pi over 2 right here. And remember, tangent is y over x. So the y value is 1, my x value is 0. Now, you have to recognize that if you try to take a number and divide it by 0, it is not going to work. If I have $1 and try to make it disappear, that's like making it disappear. So I can't do that. Mathematically, I probably could make $1 disappear, but mathematically we can't. So 1 divided by 0 is what we say is undefined. It's okay if it's the other way around. If it's 0 divided by 1, that's okay. If I have nothing and I split it one way, nobody gets anything. All right, in letter D, we've got the cosine of 10 pi over 3. So let's see, is 10 pi over 3 on the unit circle? So the most I get is 5 pi over 3. So 10 pi over 3 isn't on the unit circle. So we have to figure out a different way to do this. So I could, if I think about it, this is 1 pi over 3, right? And this is 2 pi over 3. This is 3 pi over 3. This is 4 pi over 3, 5 pi over 3. This is 6 pi over 3. This is 7 pi over 3. 8 pi over 3, 9 pi over 3, 10 pi over 3. So 10 pi over 3 is equivalent to 4 pi over 3. And I am trying to find the cosine, and the cosine is going to correspond to the x value of negative 1/2. If you're not comfortable with that, you could take 10 pi over 3 and change it into degrees, because I think degrees are a little bit easier to work with. But that means you would have to multiply this by 180 over pi, and you don't have a calculator on this section. So even though your pi's will cancel, you're still looking at basically 10 times 180 is going to give you 1800 divided by 3. Well, 3 goes into 18 6 times, and so that leaves you with 600. And so then what I'd have to do is subtract 360 because that number is too big. And when we subtract 360, we're going to get 240. And so a 240 degree angle is basically where we ended up. So you can look at it either way. I think it's a little bit easier just to count around and around and around until you get where you want to go, since you don't have a calculator on this section. Letter E, we're looking at the tangent of 225 degrees. So here's 225 degrees. The tangent, remember, is going to be y over x, the negative square root of 2 over 2, divided by the negative square root of 2 over 2. Okay, and remember, when we're dividing fractions, it's the same as multiplying by the reciprocal. Now you could see right now that I'm dividing a number by itself, and so no matter what I do, I should end up with a positive 1. Anything divided by itself is 1. But if you forget that, then when we divide fractions, remember, we're going to take the top number, and that's negative, and multiply by the reciprocal of the bottom number. So that would be negative 2 over the square root of 2. When I multiply across, I'm going to end up with a positive 2 over the square root of 2, or 2 times the square root of 2, over 2 times the square root of 2. Everything cancels to 1. Okay? In letter F, we're looking at the sign of negative pi over 2. This, again, is one where if we've got a positive pi over 2 up here, then a negative pi over 2 is going to correspond to 3 pi over 2, or simply 270 degrees. And if I am trying to find the sign, I'm looking at the y value, which is negative 1. All right, let's take a look at number 20. Now we're getting back to what we know about normal distributions. There aren't that many stat problems on the final, but this is one of them. So you do have to remember some basic properties about a normal distribution. With a normal distribution, the mean is in the center. So the mean of this distribution is 10. I guess I can just do that here, right? And we use the mu symbol for the mean. So the mean is 10. The standard deviation, remember, there's 3 standard deviations on either side, and so the distance between the mean and the first standard deviation is going to give you the value. So notice that our intervals are counting by 2. That means our standard deviation, which we're going to use the Greek symbol sigma, is equal to 2. All right, so in letter B, it's starting to ask more about the percentages. Now, this is an area where you can't use your calculator, so you can't use your normal function on the calculator. You have to remember the empirical rule, which basically tells us that 68% of the data, actually let me do a darker color, 68% is within 1 standard deviation, 95% of the data is within 2 standard deviations, and 99.7% of the data is within 3 standard deviations. And that's true for every normal distribution. So if I want to know the percent of the distribution between 6 and 14, that's 2 standard deviations away from the mean, and that's 95%. This may be something you want to jot down on your index card. In letter C, it says what percent of the distribution is between 4 and 12. Now this one you have to be a little bit more careful because it's not centered. So if I'm looking at my 12, that's 1 standard deviation away. And so let's see, the easiest way to do this problem. So for example, I know that, use a red pen here. So I know that this distance here is 68%. I need to figure out this distance. And so if I look at it, that's beyond 1 standard deviation away from my mean. So if I think about what's on either side of 68, I know it's got to be 32% because 68 plus 32 is going to be 100%. So together, these tails add up to 32%. But if I'm only interested in this tail, I'm going to cut that in half, and that gives me another 16%. And so if I add together 68 and 16%, we end up with 84%. All right, now in number 21, it says, suppose the distribution in number 20 describes the results of a simulation of 10,000 trials of a certain random process. If you perform a similar process once and obtain a result of 7, would your result provide evidence that your process is different from that in number 20? Use probability to justify your answer. So I'm looking at 7, and 7, it's kind of hard to see because I've written over this, but 7 is somewhere in here. This is where 7 is. Notice that 7 is within 2 standard deviations of the mean. And so since 7 is within 2 standard deviations of the mean, it's not unusual. Okay, and remember we defined it unusual to be something that occurs less than 5% of the time. And this occurs more than 5% of the time, so we're not going to worry about it being unusual. Since 7 is within 2 standard deviations of the mean, it's not unusual. In fact, if you wanted to use probability, since it's within, it's in the 95% range, so it's going to occur more often than 5%. Oops, I spelled that wrong. Occur more often than 5%. Okay. Now in part B it says, suppose instead we obtained a result of 15. Well, look where 15 is. 15 is way out here. 15 is beyond 2 standard deviations. So since 15 is beyond 2 standard deviations, of the mean, it occurs less than 5% of the time. It is considered unusual. And it does provide evidence that something about our sample is different. Okay. All right, just a few more. In number 22, it says, suppose a polynomial has the following roots. We have a double root at 3, a triple root at 0, and a complex root at I. It says to write the function in factored form. So a double root at 3, that means my x-intercept is at 3. That gives me a factor of x minus 3. Since it's a double root, make sure you put your exponent on the outside of the parentheses. I've been seeing a lot of students writing it here next to the x. It's the root that is squared, so you want to square the quantity. We have a triple root at 0, so you can either write that as x minus 0 or simply x, and a lot of you have just been putting the x up front. Since it's a triple root, we want to make sure we cube it. And we have a complex root at I. So we're going to write the factor the way we did anything else. It's going to be x minus I. What you have to remember, though, is all your complex roots are going to come in pairs. They're always complex conjugates. So if I have an x minus I have an x plus I as well. And so you have to recognize that. Number 23. It says use the graph to factor the function x to the 4th minus x to the 3rd plus 4x squared minus 4x. Now this actually might be something that we can use grouping for. And I'm going to try, since I have 4 terms, I might not even need the graph. But if I do, I'm going to show you both ways. So if I don't need the graph, then I should be able to factor this using grouping since there's 4 terms. I'm going to go ahead and pull out x cubed. And if I do that, I'm left with x minus 1. In the second quantity, I'm going to pull out a 4x. And when I do that, again, I'm left with x minus 1. And so what I'm going to do is I'm going to go ahead and use my grouping. And I'm going to have x minus 1 times the quantity x cubed plus 4x. Now, I actually didn't do what I should have done, and that is look at the original quantity and see if there's something I can pull out of every term. If I look at f of x, I actually see that since every term involves an x, I could have pulled that out first. Instead, I see that in this quantity, there's still an x in common, so I'm going to pull it out. So if I do that, I'm going to get an x times x squared plus 4. And over here, I still have the x minus 1. I'm just going to put that down here. So this would be the equation in factored form. If I wanted to use the graph, then I would simply use synthetic division to do the same thing. So for example, I know I have an x-intercept at 0, so I'm going to put the 0 on the shelf, and then I'm going to list all my coefficients. The one thing that I am missing is a constant term, so I need to make sure I put a 0 there. So that means all my coefficients are going to be 1, -1, 4, -4, and 0. So I have 2 x-intercepts. That means I'm going to actually have to do the synthetic division twice. If I bring down the 1, and then I multiply, I get 0. Add, multiply, add. 0 times 4 is 0. I'm going to add, and then when I multiply, I get 0. So I have no remainder, which is good. So what I'm left with, though, I'm going to take down 1 more time. So since I have another x-intercept at 1, I'm going to put that on the shelf. And then I'm going to do synthetic division again. If I bring down the 1, multiply, 1 times 1 is 1. When I add, I get 0. 1 times 0 is 0. When I add, I get 4. When I multiply, I also get 4, and then again I got 0. And so since I started off with x to the 4th, and I pulled out a factor of x here, this would be x to the 3rd. So this is x squared. So this final quantity is x squared plus 0x plus 4. And so if I think again about my factors, the 0 is just a factor of x, the 1 is a factor of x minus 1, and then this is my final factor. So again, if I put them all together, I'm going to have x times x minus 1 times x squared plus 4. So this is one that you could have just factored it using grouping, or you could use your x-intercepts and synthetic division to write it in factored form. Lastly, in number 24, you're given a polynomial f of x, but notice that you don't know the constant term. It says, for what value of p will 3x plus 5 be a factor of the polynomial? And so if it's a factor, that means it divides evenly into the polynomial. So I don't want any remainders. So we got to figure out a value for p to make that happen. So this is something I have to do long division. So I'm going to have 3x plus 5. And then I'm going to have 3x to the 4th plus 8x cubed minus 10x squared minus 28x plus p. And I don't know what p is. So when I start doing my long division, remember we're not looking at how many times does 3x plus 5 go into that huge quantity. I'm just looking first at my first terms, 3x and 3x to the 4th. What do I need to multiply 3x by to get 3x to the 4th? I already have the 3's, so the only thing I need now are 3 more factors of x. I'm going to put that over my second term, since what I'm dividing by is 2 terms. Now I multiply. X cubed times 3x gives me 3x to the 4th. X cubed times 5 is going to give me plus 5x cubed. Now remember, with long division, you must subtract, but you have to subtract both terms. So my x to the 4ths cancel. I've got 8x cubed and a negative 5x cubed. Together that gives me 3x cubed. And now I think I'm going to drop down my negative 10x squared. Now I'm going to think, what do I need to multiply 3x by to get 3x cubed? Well, I got the 3's. Now I need an x squared. So x squared times 3x gives me the 3x cubed again. And x squared times 5 is going to give me plus 5x squared. Again, we need to subtract, but I subtract everything. My 3x cubes cancel. I've got a negative 10x squared and a negative 5x squared, which is a negative 15x squared. And I'm going to bring down my minus 28x. Okay. Now I'm thinking, what do I need to multiply 3x by to get negative 15x squared? So I need to multiply 3 times negative 5 to get negative 15, and then I need another x. So I'm going to multiply by negative 5x. When I multiply through, negative 5x times 3x is negative 15x squared. And negative 5x times 5 is going to give me a negative 25x. And now I'm going to subtract. But remember, when I'm subtracting two negatives, or when I'm subtracting a negative, it ultimately makes it positive. So both of those are going to become positive. My x squares cancel. I've got a negative 28x and a positive 25x. So that gives me a negative 3x plus p. And I'm still trying to figure out what that is. But remember, I don't want any remainder. So what do I need to multiply 3x by to get negative 3x? Well, I need a negative 1. Now I'm going to multiply through. Negative 1 times 3x gives me a negative 3x. Negative 1 times 5 gives me a negative 5. The next step is to subtract. When I subtract, both of these become positive. So basically, when I add, I've got p plus 5. Now remember, I don't want a remainder, so I need that to equal 0. So what value of p will lead to a no remainder, or a remainder of 0? If I subtract 5 from both sides, I find that p will have to be negative 5. And so that's what I need this number to be. P equals negative 5. And if it's negative 5, then my factor 3x plus 5 will divide evenly into that polynomial. All right, that's it. If you can do each of these problems on your own, then you are good to go on the final. Good luck, you guys. You've worked really hard this year, and we're all really, really proud of you.